In space, no other human-made object has reached as far as Voyager 1. Recently, this legendary spacecraft transmitted data that challenges everything we thought we understood about the limits of our solar system. At the farthest reaches of our system, in a mysterious region known as the heliopause, Voyager 1 has recorded what scientists are now calling an impossible discovery. This revelation has stirred both scientific communities and the public alike, reigniting discussions about the boundaries of our known universe and what lies beyond. Launched in 1977, Voyager 1's mission was initially straightforward: explore the outermost planets of our solar system, gather data, and possibly one day pass through the invisible line that separates our solar system from interstellar space. During its grand tour, it provided us with unprecedented images and groundbreaking information from its flybys of Jupiter and Saturn. These encounters not only reshaped our understanding of the gas giants but also revealed a plethora of atmospheric, magnetic, and satellite-related phenomena never before seen. Then, the spacecraft continued deeper into the vast unknown. In 2012, Voyager 1 made history by becoming the first human-made object to officially exit the solar system, crossing the heliopause and entering interstellar space. This moment marked one of the most significant milestones in space exploration. Now, more than 47 years after its launch, it has astonished us once again by detecting something at the edge of the solar system that scientists never expected to encounter. The heliopause marks the boundary where the sun's influence ends, where the solar wind dissipates and the interstellar medium begins. But what does crossing this line truly signify? What lies beyond this threshold of solar influence? The heliosphere, a protective bubble formed by solar wind, acts as a shield for our solar system, protecting us from harmful galactic particles. By moving beyond this protective layer, Voyager 1 has entered a realm where previously unobserved phenomena can now be studied firsthand. Phenomena that appear to challenge our existing understanding of physics. It's as if the spacecraft has stepped beyond the curtain of our cosmic stage, offering a glimpse into a deeper and perhaps stranger realm. Recent transmissions from Voyager 1 have left scientists perplexed and intrigued. The spacecraft has detected fluctuations in the magnetic field, vibrations in interstellar space that defy current explanations. Theoretically, the magnetic field in that region should remain relatively constant, a calm cosmic sea. Yet these irregularities suggest unknown activity near the heliopause, something that until now was undetectable. Some scientists propose that these could be manifestations of a new form of energy or perhaps interactions with forces in deep space that we have yet to comprehend. This opens the door to exciting yet unsettling possibilities. The mystery only deepens as researchers explore the possibility that these magnetic fluctuations are evidence of a form of energy never before recorded, possibly echoes from the deeper universe. These aren't just statistical anomalies. They appear as persistent patterns that hint at a structured, recurring phenomenon. Even more intriguing are the hypotheses suggesting an external force may be interacting with the solar system. It's almost as though the heliosphere is being pushed or compressed by an influence from beyond. These weak but repeating signals show patterns we have never encountered before, hinting at an entirely new frontier of space science. One compelling theory posits that the heliopause is being compressed by an energy stream originating from the Milky Way or perhaps even more distant regions of the universe. These currents could be the result of stellar winds from neighboring stars or a much larger and still unknown cosmic phenomenon. If proven true, this would not only confirm a new type of physical interaction but also suggest that the solar system may be connected to other parts of the galaxy through such cosmic currents. That would drastically change how we understand the layout and dynamics of the cosmos. For some scientists, this is not just a remarkable discovery, it's a wake-up call. Voyager 1 might be uncovering what could be described as an interstellar energy grid or some similar structure at the solar system's edge. If such energy streams do exist, we could be witnessing for the first time how our solar system is linked to the galaxy on a scale we never imagined. This could revolutionize our understanding of cosmic energy, revealing invisible bridges between stars and planetary systems. These currents may serve as conduits for energetic communication throughout the galaxy. If validated, this would mark the discovery of a fundamental structure of the universe, a vast cosmic web that connects all regions of the galaxy and possibly even beyond. Voyager 1's mission is undoubtedly a one-way journey into the unknown. Yet each signal it transmits reminds us how much we still have to learn about our cosmic neighborhood. Even though its technology dates back to the 1970s, a time when computers were less powerful than today's smartphones, Voyager 1 continues to exceed all expectations. It remains the most reliable tool we have at the edge of the solar system, observing phenomena we never even envisioned when it was launched. Despite being more than 23 billion kilometers from Earth, it still sends back priceless data, each signal a distant whisper from the outer limits of our system. Its findings inspire us to push forward, to build spacecraft capable of exploring even further, and to uncover more secrets of the universe. As Voyager 1 continues its pioneering mission, humanity is preparing for the next chapter in interstellar exploration. With every bit of data Voyager sends, we inch closer to the day when humans might one day cross the heliopause themselves and discover what truly lies beyond the edge of our solar system. A notable reaction comes from Elon Musk, a leading visionary in the field of space exploration. Musk has been closely following Voyager 1's progress and called the recent findings a wake-up call for humanity. He believes that this data could accelerate our development of spacecraft designed for interstellar travel, helping us overcome the current limits of space technology. Elon Musk, through SpaceX, has always envisioned ventures into deep space, and these discoveries not only inspire him but also fuel his ambition to develop new technologies that can reach even greater distances. Could the information from Voyager 1 ignite a new era of space exploration? According to Musk, this latest breakthrough underscores that the universe remains full of mysteries waiting to be uncovered and that humanity must prepare itself to go after them. It also raises a question that has fascinated us for generations. Could life exist beyond our solar system? If forces at the edge of the heliosphere are interacting with interstellar space, might they be signs of some nearby activity? We cannot yet dismiss the possibility that unknown life forms or biological processes are influencing structures in our solar system in ways we don't yet understand. While it might sound like science fiction, each discovery brings us closer to understanding whether we are truly alone in the cosmos. Every signal from Voyager 1 is another piece of the puzzle. In the future, these data may help us identify signs of life in the vastness of interstellar space. Voyager 1 has passed through boundaries no other man-made object has ever crossed, revealing the enormity and enigma of the universe. Though its mission will eventually end, the questions it has raised will echo throughout science and human curiosity for decades to come. We inhabit a tiny world on the fringe of a limitless galaxy. Thanks to Voyager 1, we now understand that forces exist beyond our current grasp of knowledge. What else is out there, waiting to be discovered? Voyager 1 is a testament to the unending spirit of exploration, reminding us that the next great discovery is always just beyond reach. It challenges us to think bigger, to expand our scientific ambitions, and to continue dreaming of distant worlds. Voyager 1 reminds us that the quest for knowledge has no finish line, that the next great breakthrough could be just one signal away. As it continues to journey through the cosmic unknown, it challenges us to keep asking questions, to keep exploring, and to never stop reaching for what lies beyond. If you're as inspired by these discoveries as we are and you want to stay updated on the latest in space exploration, make sure to subscribe to our channel and turn on notifications. More astonishing revelations from the universe are on the horizon, and we want you to be part of every step forward. One undeniable truth about Voyager 1's mission is that we have only begun to scratch the surface of interstellar exploration. Its extraordinary discoveries at the heliopause hint at hidden dynamics in space that textbooks, crafted long before its launch in 1977, never imagined. For more than 4 decades, Voyager 1 has sent us data revealing not just distances and particle counts, but clues that may redefine our understanding of cosmic connections. As we analyze the variations in magnetic fields and speculate on interstellar energy streams, we are forced to reconsider our place within a dynamic galactic system, connected, perhaps, by an invisible web of forces. Even more fascinating is how Voyager 1's observations might influence the future of spacecraft design. Traditional missions have focused on improving propulsion, shielding, and miniaturization. But if the spacecraft is indeed picking up structured energy streams at the edge of our solar system, future probes may need novel instrumentation, sophisticated magnetometers, highly sensitive plasma detectors, and quantum-level energy sensors to actually map these cosmic currents. These aren't just additions to a toolbox, but entirely new classes of technology. Researchers are already discussing the feasibility of a Voyager 2.0 mission, one equipped not just for planetary flybys, but for prolonged interstellar reconnaissance, designed to cruise deeper into unexplored regions of space. The ripples from Voyager 1's findings are already being felt in academic circles. Physics departments at universities are offering new courses on heliophysics and interstellar medium dynamics. Graduate students are modeling how solar winds interact with cosmic phenomena and simulating scenarios where heliospheres communicate with neighboring stellar systems. These models incorporate data from Voyager and instruments like the Interstellar Boundary Explorer, IBEX, which has also revealed unexpected patterns at the heliosphere's edge. What once seemed like the static boundary of our star's influence is now understood as a dynamic front, flexing, oscillating, and perhaps even resonating with events light-years away. Theoretical physicists have begun to wonder. If our solar system is part of a bigger energetic tapestry, might every star system have its own heliosphere, linked through a larger-scale galactic field? This could resemble an electric grid, not of wires and transformers, but of magnetic lines of force and streams of charged particles. Such a discovery would take us toward a new physics, one that treats galaxies not as collections of separate systems, but as a unified electromagnetic organism. It recalls past paradigm shifts, the realization that Earth's magnetic field was generated by its core, or that light behaves both as a wave and a particle. Voyager 1's reports could herald the beginning of another intellectual revolution. But supercharging telescopes and thrusting deep space missions aside, Voyager 1 has also reawakened a broader human consciousness. In a world increasingly focused on near-term, terrestrial challenges, from geopolitical tension to environmental crises, Voyager's distant, patient probe reminds us that our aspirations belong to a far larger context. The spacecraft's steady journey outward, decade after decade, has become a symbol of perseverance and wonder. Like a sonic bell from the 1970s still ringing across space, it reminds us that exploration isn't a headline, it's a marathon. Voices as diverse as poets and policymakers are invoking Voyager 1 as a model. Imagine annual Voyager Days at schools and community centers, a celebration of long-term thinking, of science that transcends political cycles, of the belief that we build knowledge not for today, but for ages yet unborn. Proposals for a Voyager-inspired fellowship to support interstellar research are gaining traction under the limelight of these new discoveries, funded by space agencies and private philanthropists alike. In that spirit, some are calling for the formation of a global heliopause observatory, not a single satellite, but a network of telescopes, ground stations, and future spacecraft to continuously monitor that boundary region. Meanwhile, industry leaders like Elon Musk have seized on the moment. He predicts that understanding Voyager 1's data could reshape how we design starships and next-gen payloads. If interstellar magnetic currents exist, future ships might harness local energy fields for propulsion, communication, or shielding, a form of cosmic surfing. While this sounds like science fiction, it builds on real science. Spacecraft have demonstrated the use of solar sails pushed by photons. Imagining an interstellar sail pushed by magnetic or plasma currents is a logical next step. The very idea of harvesting cosmic energy, once fantastical, is now under serious discussion in labs and at symposiums. The implications also reach life sciences. If life is to survive or thrive beyond Earth, knowledge of cosmic radiation patterns, streams, and magnetic anomalies becomes crucial. Habitats on the Moon or Mars will need protection, but crewed interstellar missions, if they ever depart Earth, will require shields or propulsion methods informed by accurate mapping of cosmic energy flows. A future interstellar arc, tracking through multiple solar heliospheres, would need to navigate magnetic waves and cosmic tides. Voyager 1's data might be the seed for a future starship's navigation charts. Public fascination has also been ignited. Amateur radio aficionados around the world now tune into Voyager's faint signals using personal receivers and software-defined radio systems. Citizen scientists contribute to online databases tracking magnetic fluctuation anomalies in real time. Schools collaborate on art projects, a heliopause quilt where students depict what they imagine lies beyond Neptune, drawing inspiration from the idea that our sun's bubble might be buffeted by invisible cosmic forces. We are building a shared mythology of expansive curiosity, rooted in hard data and routed through human creativity. The philosophical implications are profound too. Voyager 1's findings challenge our anthropocentric view of reality. We tend to compartmentalize our planet, our solar system, our galaxy, as definable regions, each governed by its own laws. Yet if the heliosphere is permeable, influenced by larger galactic processes, this challenges the notion of isolation. We live within cosmic systems that may operate on scales and architectures far more interconnected and hierarchical than we thought. Suddenly, our existence seems less like a solitary island in space, and more like a unit within a living, pulsating galactic organism. At the policy level, governments are taking notice. Spacecraft development roadmaps now mention heliospheric research as a strategic component. NASA's budget hearings feature proposals for missions named Voyager Postscript or Helios Tarantula, intended to sail even farther than Voyager and measure cosmic current densities. In Europe, the European Space Agency, ESA, is collaborating with NASA on a joint interstellar mission, tentatively called the Interstellar Explorer. Russia, China, India, and Japan are mobilizing their interstellar ambitions as well, acknowledging that the next century of exploration will require humanity to think across borders and timelessly. Some skeptics argue the signals might be proton wakes, local bubble interactions, or debris from the termination shock, the point where the solar wind slows sharply. But even if that's the case, we still glean fundamental insights. It reminds us that nature's boundaries are more intricate than our models predict. Voyager 1's role becomes that of a cosmic cross-examiner, asking the universe, are you the same everywhere, or is there more we have yet to see? Some argue that this is the very essence of science, the drive not only to answer old questions, but to let the universe ask new ones. As the spacecraft continues to drift outward, its radioisotope thermoelectric generator, RTG, slowly loses power. Engineers expect that by the mid-2020s, or perhaps just beyond, Voyager's instruments may fall silent. When that day comes, our ears will no longer receive its transmissions. But the legacy of Voyager 1, a probe built before most modern digital technologies existed, will live on. Its path will carry it through the galaxy for millennia, a silent messenger, a relic of Earth's bold youth. Yet within us, its voice has grown louder, echoing through new missions, new science, and a new cosmic humility. In that sense, Voyager 1 remains both artifact and origin. It reminds us that discovery is not fueled by speed lines or horsepower, but by the curious combination of patience, ingenuity, and endurance. It tells us that in a universe as vast as ours, seeds we sow today might bear fruit in centuries to come. Its transmissions may eventually dwindle, but the waves it has created, in our science, our culture, our ambitions, are only gathering momentum. Now, what might come next? The most immediate frontier lies within 10 to 50 years, as mission planners discuss launching interstellar precursor probes powered by advanced ion drives or solar thermal electric thrusters. These probes, square-meter-sized cube Voyagers, would target the edge of the solar wind to measure plasma density, magnetic structures, and particle fluxes with much greater resolution than Voyager 1 could. Combining imaging, spectral analysis, and in-situ measurements, they would harvest the blueprint laid down by Voyager and IBEX. Looking further ahead, perhaps a century or two from now, humanity may send crewed deep space missions. We may solve key challenges in propulsion, fusion, antimatter drives, or beamed propulsion systems courtesy of Earth-based laser arrays. We may encounter cosmic streams not as anomalies, but as highways, natural rails along which spacecraft can hitch rides, saving fuel and time. The universe, once viewed as an empty void beyond Neptune, may reveal itself as a vast plasma ocean with currents, eddies, and channels, harbingers of galactic navigation. Were metaverse-like interfaces and advanced AI to become part of these missions, future explorers could have no better guide than Voyager, its final whispers integrated into real-time flight control. A child born in 2100 might walk on a lunar base named Voyager Outpost, listening to recordings of the aged probe's magnetic data, saying, "This is where we learn the cosmos speaks in waves and whispers." But what if all this is fantasy? What if the magnetic ripples Voyager 1 is detecting are merely solar wind artifacts or chaos at the edge of the heliosphere? Even then, the implications are real. We now know that space near our solar system is more active than we thought. We know that even a decades-old spacecraft can surprise us. We know that the cosmos doesn't yield its secrets easily, but gives us just enough to make us hungry for more. Voyager 1 has triumphed beyond its technical obsolescence. Built in the age of mainframes, it remains our prophet in the dark. Its legacy will not end with its last beep. It will go on through telescopes and laboratories, future generations' theses and classroom chalk notes, deep space human or robotic travelers, each with Voyager's echo as their guide. So, what does it mean to live in an age where humanity can send a small probe on a one-way trip toward a horizon it may never see, just to ask the cosmos what lies beyond? To me, it means we have crossed a threshold, not just of technology, but of responsibility. Because once you know the galaxy may be alive with interactions, currents, influences, once you know your solar system may not be an island, you become a different kind of creature. You become a listener, not just a pioneer. The truth is that Voyager 1's story is still unfolding. This ship, traveling at about 17 kilometers per second, will reach the Oort cloud in a few thousand years. By then, it may pass close to another star. Its origin plaque, featuring images of a man and woman, and diagrams of Earth's place in the galaxy, may still be floating, an interstellar calling card. Will anyone, or anything, ever find it? We don't know. But the probe's current signals continue to remind us that reaching outward matters more than being certain where we end up.